I am Rivoningo Mageza, and my partner and I, Kamogelo Moukangwe, have the topic Will Today Have an Air Quality Exceedance, a ground level ozone predictive modeling project. So, South Africa has some of the strongest air quality legislation on the continent, including our Air Quality Act, which directly addresses pollutants such as ground level ozone and their impact on public health. However, our research and development on air quality forecasting, as well as early warning systems, are limited and not on par with these laws and governance structures. This project sought to investigate whether we could use historical ground ozone levels to accurately forecast uh, ozone exceedances and therefore allow for early warnings of vulnerable communities. The aim of this project was to investigate the feasibility of forecasting ground level ozone concentrations using historical pollutant levels, as well as to develop a proof of concept early warning system for air quality exceedances. The objectives we needed to meet to achieve this aim were first to collate and prepare our data, secondly, to identify trends and key predictors of ozone concentrations in these data sets, and then develop and compare and refine our models to predict ozone concentrations, and then deploy the model through an interactive forecasting tool that users could access to receive these early warnings or just to generally see the air quality forecast. Our data set came from two sources: a partner provided data set, which consisted of station data and pollutant concentrations from SAAQIS, with our station data composed of metadata such as station names, locations, and zoning area types, and our pollutant concentrations specifically focusing on nitrogen oxides and ground level ozone. We then sourced weather data from Open-Meteo, which included temperature, humidity, wind speed, wind direction, radiation, and cloud cover. The model deployment also then uses the Open-Meteo weather forecast API for its real time data sourcing. Our methodology consisted of sourcing that data from SAAQIS and Open-Meteo, our data processing and integration, which included merging our SAAQIS readings with our acquired weather data, and then exploratory data analysis, which helped us identify trends and key predictors of ground ozone levels, and then a predictive modeling phase, which helped us determine optimal models and parameters for those models, and then finally, a web development and deployment phase, which focused on the development of an app which users could access the model through. And in terms of our future work, we think that this project would benefit if we were to investigate our data access issues, because currently there is no official SAAQIS API, and so access to their real time readings, which are more reliable, is very difficult. And then, if possible, it would be very beneficial to integrate additional data sources, such as any data or real time data on our traffic patterns, or even if there is any open data on our industrial activities, such as what our power stations will be doing at particular times. And finally, we think we could benefit from conducting further modeling experiments just to confirm if we are in fact correct in concluding that real time data would result in better performance than historical readings. Thank you so much, and thank you to our partner, Professor Rebecca Garland, as well.